we are still going to be working through the algebra content. We're just going to go, we're going to slow down the pace just a little bit. So we're going to do a topic every week. And what we're going to do is on Mondays from 1 to 2:30, we are going to be holding a Zoom session. We're going to be actually having instruction during this time, and then I'll record it and put it on Google Classroom just in case you couldn't join the Zoom session, so that you can see it later too if you need to refer back to it. And then on Tuesdays, y'all will have a vocabulary assignment. Whatever I taught on Monday, the vocabulary will be about it. Wednesday, you'll have some practice problems. And then Thursday, that same practice set is going to be actually assigned to you as a quiz. And so all this means is that on Wednesday, you have unlimited tries on the practice. And then on Thursday, that same set will be your quiz, kind of just to assess what you did learn throughout the week. And your grade comes from just kind of participation and making sure you're doing all of your assignments. Now, it would be wonderful if, you ace that quiz at the end of the week. And if I have a class that, completely aces the quiz, then I'll put in an extra grade and put in your wonderful grade. But I don't want that quiz grade to hurt you if you're still struggling through it. So your grade comes more from a participation standpoint as of right now. So that's how the layout of the week's going to go, and then Friday will be a catch-up day just for you to catch up on any of the assignments you didn't get to do during the week. We will have another opportunity for a Zoom session on Wednesdays at 1 o'clock. If you need some help or you have any questions, it's just going to be kind of like office hours for third block math. So Mondays when the instruction happens, and Wednesday are going to be my office hours where you can check in and just, let me know how you're doing, ask me questions, whatever you need to do during that time. So that is a plan for this class, and I'm going to share my screen with all of you so that you can see what to do to kind of make sure that you know where we're going. All right, so you should see the Google Classroom page for our class. So this stream gets really confusing because it's got a bunch of stuff in it. But what you can do is click over to this classwork. It's going to be much simpler if you just go to the classwork. And then the way I've organized this over here on the left, do you see these, Cheyenne, the week 1, 2, and 3?
Yep.
Okay, good. Week 1 was that first week, and any assignment from that first week is in that little folder right there. So if you haven't completed something from week 1, that's where you can find it. Week 2, same deal. Everything's in there. And then week 3, which is starting this week, is in this folder here. And when we finish this recording, we're actually you're going to see in our Digital Learning Day 11 for today, it's going to go right here. Hey, Valerie. And then for everybody that was not able to get into the Zoom session, the assignment for today is just to watch the Zoom session, and then I'm going to have a question, and you just have to respond to it in Google Classroom. If you are already on here, like Cheyenne and Valerie are, they're going to answer the question in the Zoom session, and then they don't have to go back and do anything later today. But if you are not in this session, you need to go to this assignment and make sure that you answer it on Google Classroom. So Valerie, I was explaining where some things are at. And so since this recording is going to be put up on Google Classroom later, I recommend going back and watching like the first 10 minutes of this video, because I explained some things about our grading and what we're going to be doing from here on out. Okay, Valerie?
Okay.
Okay. So what we're going to do now is we're going to move into what we're learning this week. Our topic this week is going to be polynomials. And so we're actually, for tomorrow, you'll have this set in Quizlet that you'll need to do the learn function on. And then Wednesday, you'll have these practice problems here. And then on Thursday, this same set will be kind of like your quiz grade to see what you've learned throughout the week. So these two things in Quizlet and Quizzes is what we're focusing on this week. And today, I just want to share, let's see. Yeah, okay, good. So with polynomials, there are a few vocabulary words that you need to know, and you need to know what they mean. The polynomials, just like Valerie said, has more than one term. The special one, the one with one term, is the monomial. So what we're going to do here, we're just going to kind of review. Does anybody remember what a leading term is?
A what?
A leading term.
It's the term with the highest degree.
Very, very good. Yes. So term
Oh, I got it.
with highest degree. Very good. And now I want to figure out, well, what does degree mean? Does anybody remember what degree means?
It's the sum of the exponents.
Okay, so okay, I see where you're going with that. The degree is actually the exponent. So it's basically just whatever the exponent is, that's the degree of the term. Do y'all remember what constant means? Okay, so remember letters that vary. The constant is just a number; it will never change. So it's just any
Yes,
number.
it's just a number.
Yep, that's a constant. And
I was gonna say that, but I didn't want to be like it's just a number.
Oh, you would have gotten it. Leading coefficient. Anybody know that one?
Oh man, I forgot.
So its leading term was the term with the highest degree. The leading coefficient would be the coefficient.
The highest number, maybe?
Okay, close. It's going to be the coefficient of the leading term. Remember how you said that was the one with the highest degree? Well, whatever one has the highest degree, the term out in front of it, the coefficient, would be your leading coefficient. So I'm going to show you some examples here. Y'all see my 4 examples down here?
Oh yeah, I see it.
Okay, good deal. Number 1 has 5x squared plus 4x minus 11. And I want to put a triangle around my leading term. So that's the term with the highest degree. So we've got to look at the exponent for the degree. Now, the degree also needs a box around it. So I'm going to put a box around all of my exponents. There's one. Do y'all see any more exponents?
No.
Nope, that's our only exponent. And if that's really our only exponent, then that's going to be our biggest exponent or our highest degree, which means that we need to put a triangle around this term right here because it's our leading term. So what do you think the constant in this one is?
4.
11.
Okay, Damon, your audio is working. Yes, yay. Okay, the 11 is the one without the variable, so that's the one that will never change. So Valerie, we need to put a diamond around the 11 because that's our constant. What do y'all think we got one thing left, the circle, our leading coefficient. What number do you think is our leading coefficient?
4. That's the only one that's not circled, but I want to say 5. I don't know why.
Okay, Valerie, you're on the right track. This 4x is not our leading term, and our leading coefficient has to be the coefficient in the leading term. So if we know that the leading term has the triangle, we need to look inside the triangle. And the coefficient is just the number out front of the variable. So the 5 is our leading coefficient. All right, so I'm going to do one more example, and then y'all are going to tell me what I need to actually circle and put our shapes around. So number 2, I'm going to go ahead and put my boxes around all of my exponents. Those are my degrees. And then for my leading coefficient, I need to know where my leading term is first. So my leading term has the highest degree. So if I'm comparing the 2 and the 6 is bigger. So I'm going to put a triangle around that. And then the leading coefficient is the coefficient in that triangle. So the leading coefficient is that 20. And then last but not least, our constant. That is our number that doesn't have a variable with it. Do you guys see a number without a variable?
12.
They all have C's with them. We could create a constant. Y'all tell me some number that y'all want to be the constant of this example.
42.
Yeah.
Just 42? Okay. If I add it like that without the C, then we can actually put our diamond around it because that would be a constant. It cannot have a variable for it to be a constant. All right, so y'all tell me on number 3. What do I need to put boxes around?
3.
2 and 4.
Okay, so these little ones up here?
Yeah.
Very good. Those are our degrees. Which term is our leading term?
3.
6.
9.
No, 9. 9's right.
Is it? Okay, so the degree is 4 for this one. Is that the highest degree?
Mm-hmm.
Yeah, so y'all are right. Very good. So we're gonna put a triangle around this. And what do we need to do with the 9?
Add it to itself.
What shape do we need to put around it?
Circle.
Yep, because it's our leading coefficient. Can we put a diamond anywhere?
Not yet.
No, we don't have a constant. Y'all can tell me a constant. What constant do y'all want to add here?
5.
5, okay. Then I can put a diamond around that, and it's a constant because it does not have a what with it.
Variable.
Very good, very good. All right, last example, 4x squared minus 12. So how many exponents do y'all see here?
Just 1.
Okay, so I can put my box around that. So that means that this 4x squared is called our leading what?
And you need to put a diamond around the 12, right?
Yeah, because that's a what? What was
That's
that?
it's a constant.
Very good, a constant number. And this one up here is your leading term. So what does that make it the 4?
Variable. I mean, constant.
Oh no.
So if the 4 didn't have that x with it, it would be a constant. But since it has that x attached, it's known as the coefficient of that term because it's right in front of the x. So if
That's
it's,
what I meant. I read it wrong.
you're good. If it's the coefficient of the leading term, then it's the leading coefficient. So I'm going to put a circle around it. Okay. Now, this is just vocabulary, and tomorrow's assignment will be you practicing this vocabulary in Quizlet. So there is an alternative where you do it in the textbook. You write out the words and the definitions. But I really, if you have internet access, I would recommend doing the Quizlet just because it is more practice and you get to actually, I feel like you learn it more that way. But you can write them down if you don't have internet access. That's fine. All right, so now what I'm going to do is I'm going to share a different screen. Let's see if y'all can see this. Can y'all see this screen?
Yes.
What do y'all see in front of y'all?
X plus X, 2X.
And 2x.
Very good, very good. Okay, so you're right. Can y'all see my my mouse actually? What I'm
Yes.
circling?
No.
You can't see my mouse?
No.
Let me see if I can do this. Visible. Can you see my mouse now? No?
No.
Okay, it's not letting me do my highlighter pen action, but maybe I can do this. I think somebody was annotating earlier. Ooh, I can do this. All right, so this x plus x over here on the left. Well, let me make sure I got this right. Okay. Oh, it's not letting me do it. Okay, x plus x, y'all said it earlier, it is 2x. But then over here on the right, this little dot here, what operation symbol does that mean?
Multiplication.
Very good. So what is x times x?
Well, it
X.
says x2, so
Okay, yes, it's
x
x
squared.
squared. Very good, very good. So we've got to remember this part with polynomials because we're about to start combining like terms and doing these operations. So on the left here, what's 2x plus 3x?
X plus 3x. Is that what you said?
2x plus 3x.
2x plus 3x will be 5x.
You just take the coefficients out front and you add them together. That's 5x. And these are monomials here because it's just one term. What about on the right? What's 2x times 3x?
I don't see that.
Wait, you don't see it?
6x.
Do you see the black screen with the problems on it?
Yeah.
Yeah. On the side.
Okay, that's what you're supposed to be seeing.
Okay.
And then, okay, so I'm gonna go ahead and show you this. The difference in the addition and the multiplication of the terms is that when you add the terms, you just add the two coefficients to get that new number. But when you multiply, you have to multiply the two coefficients. So what is 2 times 3?
6.
And then the x times the x gives you x squared. So pay attention to those symbols because the symbols are going to tell you what to do with your coefficients. Okay, so look at the screen now. If you have an idea of what the addition one, what the answer should be, let me know. So it's 4x squared plus 4x. Can you combine those?
Yes.
What do you think?
So it's adding. So it's 8x squared. I don't know.
Okay. See that there's a problem because you've got an x squared and an x. And you can't have, like you were saying, it's 8 for the coefficient, but then you were like, is it supposed to be x squared or is it supposed to be x? If you don't have the same variable with the degree there, you cannot combine them. So basically, like terms.
So I didn't have the same one. I got confused. I didn't hear you.
No, you're good.
Hold on 1 second. I'm going to go to my calculator.
Okay, Cheyenne. So, so you can't combine these. And so what you do is you leave it like that, and that's actually called a binomial because it has two terms. Think about like a bicycle has two wheels. So if you've got two terms, that's a binomial. And then this one over here, you can multiply unlike terms. It's just adding them that causes the problem. So this one will end up being 16x cubed because you take the 4 times the 4 and then the x squared times the x. All right. What do y'all think about this one? What's 5x squared plus 1x squared?
I gotta scroll down.
If you had like 5 apples and you add another apple, how many would you have in total?
Oh, 6.
So it'd be 6x squared here, and we could add those because they both had the x squared. They both have that same term. What about over here? What if you multiplied them? What would end up happening?
Then you would get 5.
You do have 5, and then what happens with your exponents here?
Oh gosh,
Remember, when you multiply with exponents, you end up adding those numbers.
okay, so it would be cubed.
Okay, one more.
What do you call it if it's
To the 4th power. It doesn't have a fancy name.
it's what?
It doesn't have a fancy name like squared or cubed. It's just to the 4th power.
The 4th power. Okay. Anyways.
Yep. Good.
I got pretty close.
All right, and then when you have polynomials like this, when it asks you to, simplify all of this, you got to think about where are the like terms? What can I combine? So you've got a few different things to look for. You've got to find your like terms first, okay? So if you look at 3x to the 4th power, the only other term that has that 4th power is the 6x to the 4th. Those are the ones you can combine together. And then when you combine them, you get 9 because you had 3 plus 6. All right. The next one we can look at is the x squared term. So we've got a -5 with it, and then over here the 2 with x squared. So what would you get when you combine -5 plus 2?
-6.
All right. So basically you owe somebody $5, and then you pay off 2 of it. How much money do you have? Are you still in debt?
4. Or no, 3.
Yes, you're still in debt 3. Very good. So that would be a -3x squared. And then the things that are left on your screen, they have that haven't been like colored on yet. They have a really special name. Do y'all remember what the name would be for this 1 and -7? I can't hear you, Cheyenne, if you're trying to answer.
I'm trying to turn mine up. I don't know how. I don't think you can.
Differ on your screen from the first problem.
What?
Are you displaying different things than the first x plus x equals like 2x?
Yes.
I only see the first problem you did.
Oh no, let me see if I can fix that.
Yeah, I can't see the other ones either.
Really? Okay, can you see my screen now? Has it changed?
Okay, I see it.
Okay.
Is it now?
Okay. I guess I can't present that in Zoom. That's weird. Okay, the 1 and the 7, do y'all see my mouse?
Yep.
Okay, the 1 and the 7 are constants, and so you can also combine those, and you would get this -6. So this 9x4 minus 3x squared minus 6, how many terms do you see here?
3. So it's a trinomial.
Exactly, it's a trinomial. Very good. So in your practice, a lot of it is going to be combining like terms, adding and subtracting, multiplying, dividing, and then also labeling polynomials by their degree and by like how many terms there are, and it might ask you for the leading term and the leading coefficient, and just so that you make sure that you remember all of this stuff about polynomials. And that's what this week is going to be about, is just polynomials. So I know I've had some success with the quizzes, so let's look at your practice just to see if you have any other questions about polynomials before we finish the instruction. So let me stop this share, and then I'm going to share right here. Okay. So first, I'm just going to go through these flashcards and see if anybody has questions about what these are. So if you contain numbers and variables and operations, but no equal sign, that's just an expression. And if it has variables in it, we call it an algebraic expression. All right. What about an expression that combines two terms? What's that one?
Binomial.
It is a binomial. Very good. Okay, what about the big number in front of the variable? What is that called?
The a term.
It's the one that we were putting circles around earlier.
Oh, is it the coefficient?
Very good. Yes. Coefficient. All right. Okay. If you have a constant difference between two terms, that's called a common difference. So basically, it has it in the definition. It's just a common difference. All right. What about a term with no variable part? So it's like this 3 right here. It's the one that we were putting diamonds around earlier.
The constant.
Very good. Very good. Yeah, it's the constant term. All right. This is what Valerie was talking about earlier, the sum of the exponents of the variables. So this 3 and this 2, if you add them together, the degree of this term would be 5. So very good, Valerie, for remembering that. All right, the greatest degree of the terms. What do y'all think that would be?
Greatest degree.
The leading coefficient.
So
No,
yeah,
crap.
Valerie,
Is it right?
the greatest one would show you that that term is the highest or the leading term, but we just call it the degree of a polynomial. You finding kind of the degree. All right. What is the answer to subtraction? Oops. Yes.
Difference. You show me.
Difference. Yeah. All right. Let's see. If it has an equal sign, what is that called?
Equation.
Very good. All right. If you have two expressions that are equal.
Oh gosh. What? Equivalent equations? What?
Yeah. So if you got two expressions and they're equal to each other, they're just equivalent. It's just a fancy name for equal. All right. Let's see. We're not going to look at that one. What is the little number up at the top, that power part? What is that called?
The exponent. Right?
Very good. Yes, it is. All right. All right. What about numbers that belong to this set? -3, -2, -1, 0, 1, 2.
Real numbers?
What did you say, Valerie?
Real numbers?
So they are part of the real numbers.
Whole numbers?
Yes, very good.
Okay. I knew it was something like that.
Well, and actually they're part of whole numbers too. But because, well, actually I would say this is a whole
Because of 0?
Yeah, I need to change this because when you add the 0, it's also whole numbers. So it's not just integers. All right, opposite operations. What is that called?
Inverse operations.
Yes, very good. All right, numbers that cannot be written as fractions.
Irrational numbers.
Irrational numbers.
It's the crazy ones, the irrational. Very, very good. All right, the coefficient of the first term when a polynomial is written so that the exponents decrease. So basically, it's the coefficient of the leading term. So that's the one that we were, let's see, we were putting circles around.
Leading coefficient?
Exactly, good, the leading coefficient. All right. Terms that have the same variable parts. These are the ones that you can combine together.
Like terms.
They're not unlike, but they're
Like terms.
very good, very good. Like terms. A polynomial with only one term.
On a monomial.
Very good, yes, very good. A number that has a whole number square root.
A radical?
Okay, that you're right, Valerie, that this little symbol here means the radical. But what
Perfect square?
yeah, the perfect squares are the ones that you can take that square root of, and it would give you a whole number out of it because it's a perfect square. The answer to division.
Multiplication?
That's the inverse of division. What is
Oh,
the answer to a division problem called? It starts with a Q. Whoa.
quotation?
Quotient.
What is that?
Quotient.
Oh,
Quotient is the answer to a division problem. All right. Numbers that can be expressed as a fraction.
rational numbers?
Very good. Very good. If you have all rational and irrational numbers together, what do we call those?
Quantities? Real numbers.
Oh,
Yep. The real numbers is the umbrella over all of those numbers. There are imaginary numbers. You'll learn later on in math. All right. If you perform all indicated operations, basically you've made it as simple as you can, then all you've done is simplified. So anytime you have directions that say simplify, it's basically telling you do all of these operations. Make it as simple as you can. All right, b is the square root of b times b. Okay, that's just the definition of square root. Used to solve a system of equations by substituting the expression for one variable in for that variable. Okay. We've done some things with equations in the past couple of weeks. And if we, like for the functions, if we plug in something for the function and get something out, we call that substitution because we're substituting something in for it. So that's just what we use whenever we're plugging something in, a substitution. What's the answer to an addition problem?
the sum?
Very good, yes. All right, parts of an expression separated by a plus or a minus sign.
I was gonna say expression, that's for the problem.
So like this 2x cubed y squared, this whole thing is called a term. So this is one term. And then this part right here, this 3x, that's another term. And then the y is another. So how many terms do you see here?
A polynomial?
It is a polynomial because it has more than one term. How many terms are there exactly?
That's a trinomial?
Because there's 1 here, 2, and 3. So kind of like a tricycle has 3 wheels. A trinomial has 3 terms. Oh, we just answered this one, didn't we? Yep, a trinomial. A letter used to represent a number. What are
A
those?
variable?
Very good. And the number 0, 1, 2. So I guess there's no negatives.
Natural numbers?
I would say natural or counting, but they are saying whole numbers. I'm going to go in and edit that. So this Quizlet is going to be your assignment tomorrow. I'm going to post it to Google Classroom, and I'm going to just say, make sure, and I want to show y'all this too. So your assignment, you see this learn part right here?
Uh-huh.
You've got to use the learn. Like after you finish the learn, you can use the match, the gravity, things like that. But do the learn first. That's what I'm going to be looking for your assignment tomorrow. So what you do is you click the got it, and then you can even go to the options right here, and you can turn off the written part so you don't have to type it in. I would turn off the flashcards too. And then go back. And then you'll only have multiple choice questions for the learn. And you can go through and learn it. Like the big number in front is the coefficient. You click on it, and you've already got one mastered over here. So
I
you're
have a question.
Yeah.
How do you know we did it?
Okay, so at the beginning of the semester, y'all logged into your Quizlet and y'all joined my class. So anytime that you log in using your school email, get that login information, it shows me what you have, like what activity you've done. So, so like for example, right here, you see how it says I mastered one?
Mhm.
If so when I go look at the class progress, it would show me that I have started the learn. But I won't have a check mark next to it until it says that you've mastered all 35 down here.
Okay.
And I'll show y'all that, what I can see. So if I go to y'all's class and I go to just the view class progress, and I haven't even assigned this, so I don't expect to see anybody like doing it yet. But if y'all were logged in here and y'all were working on it, I would see some things right here. Let me show you an example. Like this one here. Alan did some flashcards on it. Justin did the learn, the flashcards, and the test. Allison did the flashcards. Nita did the test. Wyatt started the learn. So do y'all see how I can kind of see what you're doing?
Mhm.
You got to make sure you're logged in to your school email account to make sure that I can see your work. Okay.
Okay.
So that's your assignment tomorrow, is just to do the learn. And then Wednesday and Thursday, you'll be working on these quizzes right here. So what do y'all think so far, just looking at these answer choices? Which one would be a monomial?
A.
So A has that exponent of 3. So that would tell us it is a cubic one. The highest degree is 3. But monomial means you only have one term. This one? Yes. Yeah, that one's the only one with one term, and it also has the 3 as the exponent, so that would be your cubic part. Okay, if it asks you to simplify this, what operation is in between this 5 and the parentheses?
Multiplication.
Exactly. So we would need to distribute this 5 into the 3x and the 2. So what is 5 times 3x?
15x.
So I see that here, and I see it here, right? But then we've got to check, what is 5 times 2?
10, so it would be 3.
Yep, it'd be this one right here. So we're just practicing simplifying polynomials this week.
You're drawing some there.
Yep, I'm trying to get it to go away. I guess I'm going to have to erase it. Is that better? Okay. And then you'll have problems like this too, where it says if a rectangular field has a length of x plus 7 and a width of 4x minus 2, write an expression for the length of the fence to go around the outer edges. So what do I always say about word problems? What would always help you to do first?
Oh gosh.
I'm a very visual person, so what do I always have to draw?
Square?
What?
A square?
Okay, yeah, in this case, since it's a rectangular field, it's a square that I'm drawing. But so I always draw a picture to help myself. And then once you've got your picture, you can label it. So this side over here is x plus 7. This side over here, so I got that from right here. And then the other side is 4x minus 2. And then it wants to know the outer edges. If you add up all the outer edges, what is that called? Starts with a P. What'd you say, Cheyenne?
Width times height.
Okay, you're talking about area or volume. Okay, what is the one below that? The one that's just adding up all the sides?
What?
Starts with a P.
Take it with you.
Okay.
Perimeter. It's a perimeter. So it's asking you to add up all these sides together. So you would just need to write all this out. So you'd say 4x minus 2, and then plus your x plus 7. But have I added up all the sides yet? I've only done 2 of them. What do you know this side has to be?
2x minus 2. 4x minus 2.
Yeah, exactly. It's the same thing as up here. Very good. So we've got to add that part in there again. And then we've got to add this other side over here. And what do we know that one has to be?
7. X plus 7.
Good.
Well, that's a lot.
Exactly. But once you write it all out, all you have to do is find your like terms. So like, what is like terms with 4x? What else can I circle?
The other 4x.
The other 4x. Good. Anything else?
The other 2.
Since this still has an x in it, it's considered a like term. And there's another one here. So how many x's do you have in total? You got 4 plus another one plus 4 more plus another one.
You have, whoa.
Yeah, it's 10 of them. So the only answer choice that makes sense right now is this one right here. But we can check and make sure our constants, we've got a -2 plus 7, -2 plus 7. So if we added those all up together, I think you get a 10?
7 and 7 is 14.
But then you've got to subtract the 2 from that and then subtract the other 2 from that. Does that give you a 10?
Yes.
Yeah. So the perimeter for this, it's not asking you to do very much other than just add everything together. And then the answer choice would be this one here. Before I move on, do you have any questions about this problem?
No.
Okay. I'm not going to do all of these just because I want you to do some of them on your own whenever you do the practice on Wednesday and the quiz on Thursday. But these are the problems that you're going to be doing on that day. So just wanted to kind of give y'all a chance to see it all. All right, find the sum here. So what I would do is write this down on your sheet of paper, because then what you can do is you can put shapes around your like terms. Like, for example, let me see if this is going to work. It's 2x squared. The like term with the 2x squared is this -4x squared here. So when you combine those, 2 plus a -4, you're going to get a -2. So you already know it's either this one or this one. And then the 5x, the like term with it, is the 6x. So 5x plus 6x is just 11x. And that already tells me right now that the answer has to be this last one, because this one here has a -11x. And when we combined it, we got a +11. Any questions about that, Cheyenne?
I've been taking notes.
You good? Okay. I'm going to do a few more. Which one of these is in standard form? Okay, so standard form is when you take all of your degrees and you put them in decreasing order. So if you look at all these exponents, like this one here, they don't have any exponents. This one here, the 2 is first, and then the 3 is last. If you want it in decreasing order, that leading term, the one with the highest degree, has to come first. So if you look at this third one, this is an example. You've got the 4 here, the 2 here, and then that works. Let's check and make sure this one has a 5 as an exponent, 4, 3, 1, and then nothing. So I think it could be either one of these. Which one do you think it is, Cheyenne?
I was thinking 3, but 4 also looks like it works.
I agree. I think both of them will work. Ooh, so you can actually choose 2 for this one. Okay. So whenever you're doing this practice, make sure that you choose all that apply here if you see the little check mark. Both of them are in standard form. Oh no, I'm in second spot. We need to get into first place, Cheyenne. All right, so classify this polynomial by its number of terms. How many terms do you see here?
3.
All right, so there are at least 2. You tell me, what do you think the first term is?
The first term is x squared.
The 4, so the 4 is attached to the x squared with multiplication. So we would actually count this whole thing as 1 term. And then the second term is this 2 here.
Okay.
The minus and the plus is what will separate the terms. So since we've got 2 terms, which one of these words represents 2 things?
Binomial.
Very good. All right. What about this one? It wants you to classify by its degree here. What is its highest degree?
Highest degree? 3.
Very good. So that 3 means that it is a cubic. The trinomial would be if you were counting the terms, but the degree you would use cubic. All right, let's see. What place are we in now? Oh, we're in first place. All right, very good. What do you think the degree of this polynomial is, Cheyenne?
2.
Very good, very good. All right, so that's basically kind of a summary of all the problems you're going to see in the practice and the quiz for this week. Do you have any questions about any of these that you've seen?
No, I feel like just some practice would do me good, and but I pretty well understand it.
Okay, very good. All right, so just to recap what we're going to be doing this week. And every week from now on, Monday, some sort of Zoom instruction, either be there or watch the recording later and answer the question. Because Cheyenne, you, Valerie, and Damon, y'all have already answered questions today during the Zoom session. You don't have to go to the Google Classroom and actually answer that question. It's just for the people that have to watch the recording.
Okay.
And then tomorrow, on Tuesdays, after the instruction on Tuesdays, y'all are going to be doing vocabulary. So I'll post that tomorrow. And then Wednesday, do you remember what that's going to be?
It's going to be the quizzes.
Exactly, just practice. Unlimited amount of tries. And then what will Thursday be?
The kind of like quiz.
Exactly. And it's going to be the same question set from Wednesday. It's just going to be one time, though, and you just show me what you have learned throughout the week. And then Friday is going to be a catch-up day. And that's it. And where can you find all of your assignments at, Cheyenne?
Classroom.
Exactly, yes. So if you go to your Google Classroom, don't just look in the stream. Make sure you go to the classwork, because if you don't go to the classwork tab, it gets super confusing. Let me show that just one more time. If I can make sure I pull it up correctly. So go to this classwork tab up here, click there, and every week over on the left is organized. So week 1, that's all of your work for week 1. Week 2, all of your work. And then week 3, you'll start seeing stuff in there today, now that we have recorded this session and we can post it into Google Classroom. Do you have any other questions, Cheyenne? No? Okay. Well, keep up the good work, and remember, if you're doing any work on from the textbook, that you take pictures of those and that you upload them to the assignment. I want to show you guys an example of that real quick. Let's see. So I've got this assignment here was vocabulary, and Damon actually turned in his work just with a picture, and I will take that as credit. So as long as you will attach it to that assignment and then click turn in, just show me that you have turned it in, then I will take your work from the textbook through pictures. I just got to see it somehow to give y'all credit, so just keep that in mind. All right, well, I'm glad that everybody is doing well, that y'all are still, healthy, doing well over there. If y'all need anything, please let me know. I will help in any way that I can, all right?
Yeah.
Well, I'm going to go ahead and just remember that it is up to you to make the choice to learn. I'm providing resources and instruction, and we want you to succeed at Dead County High School, and I just really hope that you have a great week and that you stay safe, stay healthy, and make wise choices. Bye.